Good afternoon. This is Greg Zimmerman, Executive Editor of Building Operating Management Magazine. Thank you for attending today's webcast, 5 Key Perspectives in Data Center Energy Savings. Our lead presenter today is Craig Deering. Mr. Deering is Critical Facilities Market Leader with HDR. With 185 offices worldwide, HDR is a global employee-owned firm providing architecture, engineering, consulting, construction, and related services. HDR is a proven leader in healthcare, science, and technology, federal and civic markets. HDR is also a leader in critical facilities and ranks 3rd on Building Design and Construction's list of top data center firms. 6 members of the HDR Critical Facilities practice are joining us today to present 5x5, 5 perspectives for energy efficiency in the data center. These panelists include Bob Haley, who leads HDR's Technology Consulting Group, Robert Finney, who is an Interim Director for HDR's Sustainable Design Services, Tom DeToro, who is the Managing Director for HDR's Toronto office and designer of the first data center to be powered by fuel cells, Bruce Johnson, who is a Mechanical Design Principal in HDR's San Francisco office, and Gary Engelson, who is a Senior Project Manager with the HDR Commissioning Group. And with that, I'll turn it over to you, Craig.
Well, thanks a lot, Greg. I certainly want to thank Trade Press and your sponsors for the opportunity to speak to the audience today. I kind of think I know why everybody might be here today. If you've been following energy efficiency in the data centers, you're certainly aware of the Times article and the ENR article that appeared last fall that basically labeled data centers as energy gluttons and essentially say that we're over-consuming energy. And it's to that point that I'd like to speak to today. The theme of perspectives was intentional, and I think part of the challenge for the data center industry is to set up a framework for conversations, not only with the press and the people that use the services of data center, but also inside of our organizations. I guess the issue of energy efficiency really struck me when I saw some of the bills that some of my clients pay, and they're truly awe-inspiring. And I think that's part of the perspective that we would like to bring to our presentation today, because our focus is really on the strategies for budgeting and accounting for our uses of energy, and to ensure that it's purposeful. And to that, and since it's such a dynamic environment, the best way to approach this is from a variety of perspectives with all the experts that can bring value, to this question. And that's why I'm glad to be joined today by my team. Bob and Robert, Tom, Bruce, and Gary. And, before we get started, I just really want to talk about the point of view that we bring to the problem. And in terms of the issues of perspective and point of view, I think one of the things that's important is all of us bring, including the audience, our expertise to the challenge of energy efficiency in data centers. But it's important that we all sort of stand in the same place and look in the same direction towards the challenge. And that's why I'd just like to talk a little bit about the point of view that we're asking that you share with us in terms of approaching energy efficiency in data centers. The first one is one about climate and comfort. And I know that we're all familiar with the ash ray zones, or might be familiar with heating degree days and cooling degree days. But I think the point of view that we bring is really looking at it as one from geographic climate. And so we like to talk in terms of these climate zones that I'm actually borrowing from the High Performance Building Series that's put out by our own Department of Energy's National Renewable Energy Lab. Because this is really like sort of the first key decision in making a decision about budgeting and accounting for our energy use. It's really where your data center is located. And in some instances, people choose a location specifically towards its advantages in achieving energy efficiency, but that's not necessarily a limitation or a constraint in achieving energy efficiency. the key thing is to understand how that climate really lays on the psychometric chart. And I don't want to steal the thunder of Bruce, who's going to talk about this in more detail, but I wanted to just share this psychometric chart for Phoenix, Arizona that was developed by our mechanical team. And in it, or on top of it, if you see the red, pink, and green lines, are overlaid some operating zones that are available to a data center operator. And this goes directly to the use of economizing in data centers. And I know that Bruce is going to touch on that more later. I think the other important point of view is to talk about work and power. And when we're talking about managing energy budgets in data centers, we're really talking about not so much energy, but power, which is the employment of energy over time to achieve work. And so when we're talking with our clients, or we encourage our clients to talk in terms more of work and power, than energy per se. The other point of view is really to focus on load over capacity. A lot of our clients may come to us and talk about, I need 5 megawatts or 10 megawatts or 1 megawatt of capacity. The key thing is really to kind of look at your load, and that's one of the reasons why I'm glad to have Bob Haley here, because he's going to talk to power-saving opportunities in setting up the IT load profiles. The other sort of two words to talk to is this issue of effectiveness and efficiency. More of the time, I like to talk about, are we using energy effectively to do the work of our data center more than efficiency, because I've seen a lot of efficiency efforts actually reduce the effectiveness of what we're trying to do. One of these happened to be the introduction of LED lighting. We actually ended up having a less effective compute floor, because though the lighting was efficient and met some of the guidelines for illumination, in a lot of ways the quality of the lighting wasn't effective for that environment. And then I think the final thing that we like to talk to is managing demand and aligning supply. Because the key thing in energy efficiency is not to need energy in the first place, and then making sure that the work that you're doing is closely aligned with the supply so that all of the energy employed is useful. And towards that, I like to talk to this slide, because in whenever you have to go up in within your organization or outside your organization and talk to your energy use, I think it's important to understand the four things that we're really trying to deploy energy to do. And I think the first one we're talking to is to protect sensitive property and equipment from climatic conditions. The other is to facilitate human comfort. The one that's probably least understood in data centers is to maintain operational availability. And of course, the most important one is to perform useful work. And to that effect, in terms of like lighting strategies, is if we are going to turn the lights, is to make sure that somebody's in the room to use them. Well, actually, I'm not going to be the only one speaking. As we spoke, HDR has brought 5 of his experts forward to share their perspectives on opportunities for energy efficiency in the data center. The first one that we're going to introduce is going to be Bob Haley. Bob Haley, again, is the leader for our technology consulting group. We have that advantage here is that Bob gives us a perspective on what actually happens in the compute environment and helps us discuss these issues with our clients and talk about opportunities to save or reduce energy consumption in the IT system. So, Bob, why don't you take it away?
Great. Thank you, Craig. And thank you, everybody, for dialing in today. And what I want to do is spend a little bit of time and just give you that IT perspective, kind of what goes on in the data center, and then ultimately what can the IT department do to contribute to power savings or to better utilization of the data centers. And with that, I'll kind of give you just a brief history of where we were and where we're going in that IT space. You know, it's not uncommon for data centers to be tagged as electrical gluttons, but over the last few years, we've seen a much better efficiency rating in some of the equipment. You know, it wasn't long ago when power supplies were designed to be 60 to 70% efficient. You know, lately those have gone up to 80, 85% efficient. That's going to relay into savings and of course, heat generation in the data centers. You know, and I think what we're seeing too, and working as a team at HDR, the way we approach client engagements is we try to get IT involved sooner in the process. We want that IT and facilities relationship to go through that design process. And with that, we kind of challenge those two groups to work together. And it's not uncommon that we see facilities groups that aren't familiar with what the IT group's initiatives are, how they sit with virtualization, what they're doing in the data center, and vice versa. You know, a lot of times when you look at the IT departments, they really aren't concerned with how much power that the data center is being consumed or what's being consumed in the data center. They're worried more about that redundancy and offering their services to their clients. So when we start to look at that, I would suggest, and one thing that if you don't do it today, you know, have the facilities group and the IT departments get together, share what they're doing. I would be interested to find out how many IT departments actually know what they spend for electricity and what their data center, what their systems contribute to that bill. That's something that if it's shared, if the IT group knows what those costs are, they can work with the facilities group on some very basic and easy fixes within that data center. You know, most standard servers, you know, consume anywhere from 12 to 1,800 kilowatt hours annually. With Energy Star ratings you're coming on, you're seeing a reduction of about 1,000. You know, sometimes depending on the number of servers, that contributes to about $400 to $500 a year per server. You start to see a fairly significant reduction in energy consumption. Then we start to take a look at, you know, how that scales down to the heating and the cooling in the data center. Your heat generation goes down, cooling requirements go down, and that has to be teamed with that facilities group. Depending on what those the set points are and the delta T's in the data center, as these virtualization strategies start to reduce the number of IT infrastructure in the data center, the data center is just going to get cooler and cooler. Then you can run into challenge with the efficiency of your cooling units. You know, with some of the newer virtualization that we're seeing out there, you know, some of these new hypervisors, you have the capability to not only utilize a single server for 60, 70 different servers, but now with some of the advanced power management capabilities, when the evening comes and the load on those IT assets decrease, that virtualization can shift and even decrease the number of servers that are being used. And that then again lowers that capability, the demand on the data center. And if you have a good group or a good relationship between that facilities and IT, depending on what you have for your management of your data center, the opportunity exists to shut some of the servers off, shut some of your storage infrastructure off, and shut some of the cooling capabilities. Free air becomes a possibility in those type of environments. So there's that opportunity to really take a look at how your IT systems work, what is required out of those systems when it's required, and then, you know, from the facilities group, you know, and from the IT group, you know, it's important that, you know, these two teams get together and understand what's going on in the virtualization world, what initiatives those IT departments have got going on, and the same in reverse. You know, the IT departments would be very interested to know how that infrastructure is put together, what impact their, you know, savings and what impact they're going to have on that cooling requirements, how that's going to go back in and be converted to energy savings by the corporation. Craig, can you switch me to the next slide? I don't have. Oh. Anyway, when we look at, from an IT perspective, this is the OSI model. Most IT people are very, very familiar with this. This is how information is transmitted throughout when you launch a request, it goes through these 7 steps and then back through till you receive it. Where IT and facilities group have that opportunity to work together in these bottom 4 layers. The physical layer, obviously, in that data center. You know, what the raised floor, you know, are all the openings, are they patched? underneath the floor? Do we have any bypass? Are they using blanking panels in the server racks? All these things, all the way up through that transport layer, are really what happens in that physical part of the data center, what more or less produces the heat load and then consumes the electrical in the data center, works up through those layers. And these are something that, again, it's important that the two groups know what's going on, know how they can impact each other, and then ultimately what can they do to possibly integrate some of their monitoring software, where the IT department, when they make these reductions, some of these processes can be automated, and then the organization sees that cost savings. I read an article not too long ago that commented on just looking at some building automation and making some set point changes in the data center and making sure that your infrastructure in that data center was efficiently engineered, can save as much as 20 to 25% on that electrical cost in that data center over a year. And depending on your size of your data center, that could be considerable. So with that, I know there's a time constraint. Craig, I'm going to turn it back over and we can go to the next presenter.
Okay, our next presenter is Robert Finney, and Robert Finney is going to present his perspective on sustainability and sustainability strategies that can be employed in data center site selection and development of the shell and other issues. Take it away, Robert.
Thank you, Craig. I appreciate it. Welcome, everybody. Thank you for this opportunity for us to present to you some of our ideas that we've been working on. Certainly, my perspective is not nearly as, I'll openly admit it, nearly as sexy as the equipment that's going into these data systems. But if you're really trying to ensure you've got a holistic solution to your energy reduction formula, you have to make sure that you maintain corrections and reductions across the board, and that really does start from the overall sense of community, that larger scale, all the way down to how well this building is put together. If you don't have the right shell or the right strategy in power generation, then a lot of the gains that you can gain through efficient equipment strategies, for example, can be lost very easily, and then it's a net neutral solution. So looking at the whole picture is vitally important for new construction and for renovation. So I'm just going to tick down here 5 separate areas. They're all somewhat interrelated, but a way to get a better sense of organization. And I do want to point out that a lot of the topics I'm going to go through work more effectively when you start pairing them up with what you're going to hear from the rest of my colleagues. So from a source standpoint, I'd say look at where that energy is coming from. And it may sound kind of strange from an energy reduction standpoint, but reliability of the energy systems that you're getting is going to have a direct impact as well. How much backup power do you need? How much emergency generation are you going to have to utilize if you're relying on an unreliable system? Consider the larger impact of the energy that is going into, say, water systems that you're putting into it too. You may not see the direct benefit from your facilities standpoint, but certainly water rates will be a direct impact, and the more energy it takes to move water around a community or to remove waste is going to have an impact, a trickle-down impact on your utility rates as well. And then finally, from a source perspective, understand that reducing on-site energy use is essentially multiplying the savings at the source of that generation via the cost of the transmission. And that cost of the transmission actually is an important aspect of the site choice. Moving on to the next bullet. Consider the proximity of your substations. Transmission efficiencies can account for a lot of energy loss and ultimately impact your bottom line as well. And then finally, look at where you're actually putting this data center, where your facility is going to be located or is already located. Consider passive strategies that may exist depending on that microclimate. For example, using a heat chimney to exhaust hot air in northern climates or nighttime passive ventilation strategies in desert climates can be very effective means and methods. The shell of the building is absolutely critical as well, and this is probably best understood in terms of energy reduction in construction techniques. Certainly don't design by the table. It's not a one-size-fits-all. You must look at that particular environment that you're located in and the building type specifically that you're looking at. It's not always just a building with data components in it. There's often a lot of program around that, or this is one component of a larger facility. Consider the whole energy system, not just one component of that, and model it. Understand in design the impacts you potentially could make, and test because, like I said, it's not a one-size-fits-all. One solution may be good for one building, and the building next door it may not be. And then look at some of the perhaps low-hanging fruit of facility development, reducing external heat gains, using strategies like cool roofs and cool site techniques, lowering the microclimate that you're having to fight against in terms of cooling load. On a cycle side, employ demand control lighting techniques, such as occupancy sensors or lighting techniques that can automatically adjust to lighting levels to meet certain tasks. This goes back to what Craig was talking about in terms of using it correctly. Understand exactly what the need is and design around that need. Design systems to reflect the use. Is a space occupied versus unoccupied, critical versus non-critical? Use that building mass for diurnal cooling. Look at high thermal mass as an option here, especially in conjunction with nighttime ventilation strategies. Those nighttime ventilation strategies can offer free cooling in a lot of climates. And in addition, a lot of utilities do offer off-peak electrical rates that can make overall savings for you. So if there's a way that you can do, say, nighttime cooling storage, it might be an effective way to reduce it from a cost standpoint. And then finally, in terms of scale, when you're looking at maybe more expensive technologies to help reduce that load, such as a renewable energy source on site, look at the scale. The larger the system, the more effective, more efficient it's going to be, and the more cost-effective it's going to be. There are a few other parts that my colleagues are going to be talking about, but I do want to point out that ultimately you're not going to be able to change what you do not know and what you do not measure. So I know that Gary is going to be talking more about this, but I did want to make the final point of make sure that you're monitoring what you're using. Understand where your energy is going, where it's coming from. Monitor, monitor, monitor. Simply understand it. Thank you.
Well, thanks, Robert. And with that, let's move forward to Tom DeToro. Tom, do you want to proceed with the electrical perspective?
Thanks, Greg, and thank you, everybody, for attending. There's lots of options we have to improve power system efficiency. Typically, we're either removing or moving components in the power path or changing a way that the data center operates, whether we're raising the distribution voltage or virtualizing servers or something to that effect, or even using more efficient components. Some of the key fundamentals that we work with when we're talking about changing the voltage or transformation, and Bob Haley talked about this earlier, is there needs to be pre-design work. Designers need to coordinate the rack voltage with IT, the server density with the IT group, and make sure that those are situated in the best positions for the electrical and mechanical distribution. Ideally, we want to stay at the highest possible voltage to reduce interim transformation levels. We want to understand where transformation occurs and how it affects the system. One of the things that we're hearing a lot now is about going to a European standard type distribution with 230/400 volts. And that's nice because the power supplies for the servers operate at more efficiently at the 230 volt level than they do at the 120/208 volt level. The higher voltage, it means less line losses and greater capacity for the same amount of distribution wiring. Some of the drawbacks, though, when we implement those are we can increase the harmonics further upstream because we've gotten rid of the transformers, and now we're not consuming those harmonics in the delta Y side. So, and then we still need 120 volt power for housekeeping loads or other tertiary loads that we have out there. And some of the distribution equipment is not widely applied in the U.S. It's available, but not widely applied. So you may have issues with your maintenance staff or with the local contractors there. Some of the other things we're seeing for distribution trends and voltage, dual inputs to the rack, whether it's a DC rack to one power supply and an unconditioned 208 or 277 volt feed to the other power supply for a dual power supply server. This places the UPS or the DC UPS at the equipment rack, and you can either operate the unconditioned power in off a UPS system in eco mode or unconditioned. So what that's doing is it's getting rid of some of the transformation in between the service entrance and your end distribution. When we look at the transformation levels, typically we're seeing 7% of the losses in the UPS and maybe 2% in the PDUs. So when we design our systems, what we look to do is specify premium efficiency transformers to help reduce some of those losses. And it's important to remember when you're talking about transformers that those losses are going to be with you for the length of your the life of your system. So those need to be looked at and carefully considered. The money you spend there, it's going to be paying you back for the life of your transformer. Try to reduce the amounts of transformation that you have in series. So if you can stay at the higher voltage, then you'll reduce some of that transformation. Look at transformer-less UPSs. One of the things that you need to be careful, though, as we drive to eliminate the transformation and operate the facility at the native facility entrance voltage, we do that to save both on the electrical losses and the price of the transformer. But when we lose that transformer, we also increase the harmonic currents that are available, and now we may need a neutral conductor upstream, where before, if we had a 3-wire feeding that delta system, we didn't have that neutral. So it's important before you go to a system like that to take all those considerations into effect. Also, one item we deal with a lot is the redundancy or reliability of the system and how that affects with partial loads. Most UPSs and PDUs operate around 40% of the rating. If we have a 2N system or redundant system, it could be down to about 35%. So understanding the system efficiency under part loads and what the anticipated loads are expected to be are important. You need to study the equipment efficiency curves at these part load conditions. Maybe employ a growth plan with multi-module systems instead of putting all your capacity in at once. And select your redundancy carefully and take those load ratios into effect. Sometimes it's better to base your redundancy on a reliability analysis rather than just saying I want a 2N or an N+1 system, and then optimize that to the application involved. When we talk about equipment, Robert brought this into the forefront here. The specifications on the equipment will yield efficiencies if you properly communicate it with your team members. So talking with the IT staff, talking with your maintenance staff, getting the right power supplies, and how the operation of the end loads are affected will yield efficiencies as well. I talked a little bit earlier about the UPS eco mode. So the eco mode, it boosts the UPS efficiency, but you're operating in some names that have been used, a high efficiency mode, a bypass mode, or a multi-mode, all carry the same meaning for the eco mode. Some have positive and some have negative aspects to them. But some of the UPS vendors may also have their own brand names for eco mode when they're running them. It doesn't mean that a double conversion UPS doesn't have eco mode as well, as they do. But one thing when designing and using that bypass side, you need to understand how the transfer from bypass back to inverter is accomplished. and what that time outage is and how that affects your equipment downstream. So that could range anywhere from 30 to a quarter cycle, depending on the technology used there. Robert mentioned about on-site power generation and the efficiencies of that. If you look at using some of the alternate technologies that are out there, whether it's wind, PV, or fuel cells as an on-site generation, you may get more efficient use of clean or free fuel sources, and that can increase your efficiency. Also, while the cost per kWh may be higher than standard diesel generators for these alternative energy sources, having the on-site generation there will increase your reliability by giving you independence from a utility grid, and that may outweigh these costs. Thank you.
That was all great information, Tom. I'm sure I'm seeing in the Q&A that you're getting lots of questions. Okay, so let's move forward with mechanical. So Bruce, do you want to pick it up?
Sure. Thanks, Greg. Well, good day to everyone, and thank you very much for the opportunity to speak with you today. I wanted to discuss some of the major issues within mechanical system design and operation that really impact the performance and energy use of these types of facilities. I'm going to touch on each of these 5 topics. Craig talked a little bit earlier about the site conditions, and we definitely want to understand these site conditions in order to be able to use them to our advantage. And I think it really begins with an understanding of the site environmental conditions. And I'm not talking about just sort of the standard, information that we typically use in other designs, which is, dry bulb design temperatures, wet bulb design temperatures. We may even look at extremes, but what we really want to look at here in the data centers is the range and maybe the concentration of the temperatures and the corresponding relative humidities. And this can be done by either collecting bin data with the coincident wet bulb or the relative humidities, or as we showed earlier, there's some psychrometric software tools that are available tied to climatic data for various locations. Again, this is the example for Phoenix. And so what you're seeing here is a couple of things overlaid. I mean, this represents the data in the colored tiles, and you can see that that's the number of hours from, minimal in the blue up to a fairly substantial number of hours in the red tiles. And so if you were to look at this, you'd say, well, in the hours that start to become significant between, say, green and red, what opportunities does that afford us? And it would certainly be a combination of air side economizer in conjunction with probably some evaporative cooling. So the other thing is that the data can also be presented as data points that you can actually see, and it's graphically a little bit easier to interpret, I believe, when you have a little dot representing a condition. You really start to see exactly where your concentrations exist. So again, these software programs are very, very effective in helping to understand your climatic conditions that exist. And then, when we couple this with, again, the operating temperature ranges that you're going to permit in the data center, this really allows us to identify the options and permits evaluation of system approaches that can be considered. And again, this is going to be focusing probably on air side and water side economizers. In some locations where you really don't want to go to the absolute minimum relative humidities within the space, you may want to look at a combination of both an air side as well as a water side economizer. And again, when you've got climates with extended hours of very dry conditions, such as the high desert in areas such as Phoenix, you definitely want to be looking at the evaporative cooling opportunities. I think the final point on site is I think it would be good to understand what the air quality is in the vicinity of the data center. I think it's good to know what your particulate content is coming in, and particularly if there's gaseous pollutants that exist in the area. You don't want to have corrosion introduced as a result of trying to implement air side economizers. So I think that information is good. Okay, on temperature, again, I'm sure probably everybody participating today is familiar with TC's 9.9 thermal guidelines for data processing environments. The document originated in 2004, really in an effort to standardize the conditions that the IT equipment was going to going to be seeing. It's then been updated to include, again, various classes, recommended zones, which again we showed on the psych chart, as well as a series of allowable zones. And I think for a majority of the work that we do, we always target to design within the recommended, which is roughly 65 to 80 degrees entering the equipment, with some minimum dew points of 42, relative humidity max of 60%, and a maximum dew point. So it sets that boundary that we were showing on the psych chart. And then there's been these expanded environmental classes, typically A1 through A4, that really allow for the systems to be operated to their benefit. One of the things that's really happened as a result of applying the ASHRAE criteria are a few things. Of course, the expanded use of the economizer cycles, which was really one of the original intentions that ASHRAE had for modifying the documents. The other thing is it permits the chilled water temperatures, if you're going with some kind of a CRAE or air handling unit approach, to be elevated, and that's going to, that could really improve chiller plant efficiencies if the chiller plant is capable of running at temperatures somewhere in the 50s as opposed to temperatures in the mid-40s. Matter of fact, even in some locations here in the Bay Area, we've got a lot of compressorless data centers that can be used, running exclusively on either economizer or in some cases economizer supplemented with some evaporative processes. I think, again, it's a combination, as Craig said before, of looking at what the site provides versus what you're going to be your operating class within the data center. And humidity, again, the humidity range has also been expanded vastly by these criteria. I think the main point I wanted to make on humidity was the fact that if you're going to choose an operational humidity and let it really rise up to one of the recommended, or excuse me, the allowable zones, you have to be sure that your chill water temperature has been coordinated with that. In other words, we want the chill water temperature to be raised to be above the dew point if at all possible. Otherwise, that chill water is not just removing heat, but we're spending a lot of energy removing the moisture. It's taking out humidity and consuming chill water capacity and energy to do that. So I think you've got to be careful that you've looked at the psychrometrics and that your chill water applications are properly aligned with that. And if you do have a need for dehumidification, say you were in a very humid zone and you did want to dehumidify, then I would decouple that from your main sensible cooling system, such that you'd have either a standalone DX, or you could even put in a booster chiller to lower the chill water temperature to that particular piece of equipment or that air handler that's really bringing in the outside air and doing the dehumidification that you need. Ventilation, that's a pretty broad topic. I mean, I wanted to just touch on outside air for occupants. Of course, we're talking about minimally occupied facilities for the most part, so there really is not much of a need for ventilation to meet outside air for the occupants. I know questions have come up in the past about the need for increased ventilation for large crews that are doing the initial equipment installation, or perhaps a change out in equipment down the road. I would typically recommend that some sort of a temporary solution be applied if that was the case, renting some kind of a DX unit to provide that additional ventilation if it's really needed. Do not spend the capital to provide a ventilation system that's got that capability in it. I think the ventilation rates for data centers are often driven by a couple things: making up for exhaust from spaces such as battery rooms, and also providing positive pressurization for the building to minimize uncontrolled infiltration. We don't really want the temperature or relative humidity impacts of air migrating into the facility, so if we keep it under positive pressure, we can control it. And if you do have a ventilation system that's tied to providing your active humidity control, that air handler may bring in that outside air, provide humidification when needed, and may recirculate some of that air from the data center back out as part of a dehumidification cycle. Lastly, under this topic, basically air management. Need for containments. It's really driven by the level of rack power. I'd say when you start to get above 4 kW per rack, you may want to start thinking about some form of containment for your hot or cold aisles. If you get up to 8 to 10 kW per rack, I'd say it's mandatory that you've got some sort of a containment system in place to be able to continue to provide the efficient cooling for the spaces. And then finally on the systems, systems really that we've applied are, again, evaluated on a site-by-site, facility-by-facility basis. I mean, these have consisted of, I'll say, systems that were achieving reliability through simplicity. Of course, incorporating N+1 design for the components, but these would be things like air-cooled chillers with, Cray units within the space, DX crack units with remote air-cooled condensers, or possibly dry fluid coolers for the condensers. Now, you can certainly enhance the efficiency of these systems if you're able to provide airside economization to either these Cray or crack units, which there are some components that add a mixing chamber above them if you have access to exterior outside air. And of course, the addition of a water side economizer to even an air-cooled plant will certainly help if you've got the right climate. And you can do that with either just pure dry coolers or possibly an evaporative fluid cooler to provide a lot of free cooling during the colder temperatures. Then we've seen applications where we're moving into the rooftop air handling units, again with airside economizers, sometimes with a form of either direct or indirect evaporative coolers, and of course probably for most climates some form of mechanical cooling, either chill water or DX to handle the extremes. And then for maybe large-scale facilities, you can start to consider central chill water plants. I'd say this is more of a rarity unless you really had something on a very, very large scale. They require substantially more first costs. They're going to require a lot more maintenance. They will provide much better energy performance if you're in a climate zone where you have extended periods of mechanical cooling required. I know, again, we found through our designs that typically larger machines in the range of 1,200 to 1,500 tons per unit are usually optimal. I think the biggest concern that sometimes comes up on a water-cooled plant is now you've got another critical utility, that being the water for the cooling towers. And so depending upon utility availability, sometimes it requires on-site storage, which becomes very expensive and consumes a fair amount of real estate. So let me just conclude by saying that the determination of appropriate systems and the most energy efficient systems do need to factor in what we've talked about: the sites, the inside operating conditions, capital available for the enhancements on the systems. And I think all of those options should probably be run through life cycle cost analysis, to truly evaluate, the various options and then make an informed decision on what would work out best for that specific facility. So.
Well, thanks a lot, Bruce. And I just want to kind of tie up one point. I'm sure a lot of people are familiar with PUE calculations. There's also WUE, or water use calculation, or water use effectiveness. And, Bruce brought in, the water as a critical utility, and Robert brought in the fact that water actually has a energy cost. You may not pay it in your electric bill, but you pay it nonetheless. And so that's something to take into consideration. And we're going to close like we do every project with our commissioning agent, who finds the gremlins in the work we just produced. And with that, let me pass it on to Gary.
Well, thank you, and thank the attendees for joining us today. And I have to agree, I see you've left the best for last here, which is the commissioning. We heard from the panelists today mention analyzing, aligning, managing, maintaining, system scheduling, redundancy, and several other things. And what we aim to do with commissioning is to improve the occupant comfort in a building while improving the system's performance. But we have to adhere to the owner project requirements, and many of these terms that were used relate back to the owner project requirements. So how do we do that? And the commissioning approach is very important. The first thing we need to do is to be sure and engage a commissioning team that has design, engineering, installation, testing, and operations experience. You know, hiring one super person and think that they would have all the MEP, engineering, and operation skills is just not going to happen. We need to establish criteria for the job. Are we going to commission the MEP systems in the building envelope or something less than that? This all needs to be reflected in the owner project requirements. During the design phase, we have an opportunity to enhance the maintenance requirements that have been designed into the project. But along with that, we want to create smooth transitions from design through the construction process and into operations for our client. We're going to look at equipment access and maintainability and the ability to replace parts and pieces that wear out. Obviously, we're wasting energy if either of those aren't taken care of. And we also want to make sure we're not overcomplicating control strategies in the design process. During the functional and integrated testing phase, I feel one of the important things that often isn't talked about is let's establish a commissioning schedule for the project that requires pre-testing of systems, and let's make sure that the time necessary to pre-test and functionally test the systems, that we're not compromising the amount of time it takes our balancing teams to get in there and properly balance the hydronic and air systems. If we squeeze that subcontractor, we're likely to end up with a project that doesn't function the way we want it to. We've got to align the test scripts for the functional and integrated testing with changes that have been made during the submittal phase. So that's another thing we're looking to, is to make sure that we're staying current with changes that have been made. And finally, we really need to zero in on the set points of these systems after we've had the opportunity to look at trends and fully analyze them at the end of the job. So moving on into the maintenance and operations piece, we want to make sure that our client and their operations staff have received as-built documentation and O&M manuals so they can properly maintain these things. The staff, these people need to be properly trained. If they're not properly trained, what we'll end up seeing is systems that are put into the hand position shortly after the job has been completed, and then we'll be wasting energy. Thirdly, we should be considering a recommissioning plan to sustain the efficient operation of these systems, and the commissioning team should be helping to do that. And finally, as we move on into the warranty phase, this is often when the deferred tests are done. They could be seasonal tests done during the coldest or the hottest day of the year, or in the case of data centers, of course, we want the buildings fully loaded so that we can really see that our primary and secondary systems are operating correctly and our redundancy in our power systems is sufficient and working correctly. And one of the ways, one of the things we also do during this final phase is to evaluate what energy has been consumed, look at the energy model that was put together, look at system trend data, and then make those final set point adjustments on the systems. And to wrap things up with the client, we really need to look at any outstanding issues from the construction phase. There may have been usage changes. I mean, these projects often take 2, 3, 4 years to construct. And at that point, we need to work with the owner and have a resolution plan to deal with those items. And the commissioning team is perfect for assisting with this. Again, thank you for your time today.
Well, this is Craig Deering. I just want to thank the HDR team for joining me today. But before we close, I just want to share a couple of ready sources with the audience if they're looking for more information. I happen to be a big fan of the Department of Energy Efficiency Renewable Energy site. If you do go there, they have a lot of tools and documentation that's very helpful in developing an energy efficiency or energy savings strategy for data centers. One of the things that I can recommend is the DC Pro software tool suite, which is the second item in their list here. Another thing I can recommend is the Federal Energy Management Program. One of the things that's useful there are a ready list of energy efficient products and list. You can also find there this best practices guide for an energy efficient data center design. And here again, here is those covered product categories that give you lists of computers, displays, monitors, enterprise service, pumps, motors, all of the components that could be part of an energy efficient data center. And of course, I can also recommend some of the websites of our sponsors. They also have online tools that I find very helpful.
To the attendees, we do have some time for questions and answers, so please keep the questions coming. And Craig, I think the best way to do this is just I'll ask the question, and then you can toss it off to one of your colleagues who could best answer the question. So as Wendy mentioned, the first question here is about fuel cells, and the attendee is just asking, what sort of fuel cells have you used and had success with?
I'm going to pass that one on to Tom DeToro.
Thanks, Greg. Fuel cells we've used before were United Technology fuel cells. They've since been bought out by Clear Edge, and we used those, I think the installation was in 1999, the first installation, and that was for First National Bank of Omaha for their data center. Successfully used them. They've been operational since then. No failures to the system whatsoever. The owner is able to maintain them, has done quite a bit of research on them with the length that they've had them. So we've been pretty happy with them.
Hey, Tom, can you tell them what technology that fuel cell style uses?
Yeah, that's a phosphoric acid fuel cell. And that's, in case you don't know what a fuel cell is, they are operating, it's a chemical reaction versus a combustion reaction that causes the generation of electricity. So they're a little more efficient. We are also able to reclaim the heat off of them. So we're getting around 50 to 60%, depending on the amount of heat reclamation that we get efficiency from those, and they are operating on natural gas.
Okay, very good, thanks. Craig, attendees asking, what are your experiences with continuous commissioning for data centers?
Well, I'm going to let Gary handle that, but I know there's actually a lot of developments in the field on monitoring and continuous commissioning, so if Gary doesn't pick them up, I'll close for him. Gary?
I'd be happy to have you close on this one for me, but commissioning, continuous commissioning probably has more than one definition. I like to think of it, at least with our group, that, and especially during that 10-month phase, that we're making regular visits back to the site, looking at control systems or the people that have been trained, looking at trends, power that's been used during that 10-month period, and tweaking and refining set points of systems. And certainly having a plan then for after the warranty phase that we get back on a regular basis, using the same scripts that were used for functional testing and retesting those systems and checking calibration. This is going to not only result in the operations staff having a better understanding of their building and what they need to do to keep it running efficiently, but it will help to identify issues that we really don't want to leave our clients with. But can you add to that?
Actually, you gave me a great setup, Gary. I think the key thing in continual commissioning or ongoing commissioning is to know that you want that functionality when you do your initial commissioning plan, and to have an understanding of whether that's going to be an in-source activity or an outsourced activity. Many data center operators are very sophisticated, and they have some of those commissioning skills in-house. So in terms of setting up those commissioning scripts, or use your outsourced commissioning agent to help set up that continuous commissioning program, I think is the biggest guidance I could give. The other thing is to investigate a DCIM system, which is a data center infrastructure management system, which helps you do trending analysis between your data center infrastructure and your IT systems. The key thing in commissioning is understanding if your data center is operating as expected or as designed. And so without those data points and that trend analysis, you don't understand if your margins of operation are heading you into trouble, or if there's deviations. Gary, if there's anything you want to tag on at the end, and then we can take on the last question.
You spurred one additional thought on my part. Often, maybe often isn't the correct word, but sometimes when we revisit these facilities to engage in retro commissioning, for example, unfortunately, sometimes we get pushback from the maintenance and operations people, as I think they believe that that it can feel like an attack on their ability to maintain and operate a building. And so I think that's just something to keep in mind as we're getting back into these buildings and helping, that there's a couple different ways to look at this, and maybe have that discussion ahead of time so that after you issue your detailed report, that it doesn't appear to be an attack on these folks.
Right, and that's a part of it, because I know that we're getting a lot of requests for data center audits. And again, that's part of the retro commissioning or continuous commissioning scope of services or perspective. Greg, next question.
Okay, great, thanks. Yeah, we have time for a couple more here yet. And actually another question about fuel cells. An attendee is asking, how is the maintenance replacement cost of fuel cell technology compared to the conventional electrical cost?
This is Tom again. When we look at the fuel cell system versus a standard UPS system, one of the ways we looked at it was to look at the overall cost per kWh of the systems and compare them against each other. That included the maintenance, replacement costs, et cetera, over a 20-year lifetime. What we found was that the fuel cells would operate somewhere around the 15 cents a kilowatt hour in the location they were at, and the UPS system for the same amount of energy was running at about 10 cents a kilowatt hour. So there's about a 50% increase in the kWh. But one of the things we found when we ran our reliability studies was there was a factor of 100 on the increase in reliability between the system that had the fuel cells versus the system without the fuel cells and just a standard UPS system. So that's how we compared them.
And this is like one thing that I want to sort of tag on. One of the, we like to talk about, sort of 4 energy budgets when we're designing data centers, and one of them is the cost of facility availability. And in that case, because of the value of the applications and compute environment that client was maintaining, that premium for fuel cells for the reliability actually came cheap. And so that's one of the things to look at when we're talking about that point of view about efficiency versus effectiveness. fuel cells were actually a very effective solution in terms of that energy budget once they weighed all the factors together.
Yeah, the other thing I'd tag on to that is there's some locations where you may have air permitting requirements or limitations, and the fuel cell doesn't have the same output characteristics as a combustion engine. So like in Southern California, they're blanket permitted, so it's acceptable there. The concentration of emissions, bad emissions coming out of a fuel cell is very minimal. Most of it is water that's coming out and a little bit of carbon dioxide. So that's one other key element to it.
Okay, very good. Thanks, guys. We'll take one last question here. This is a really interesting question. Attendee is asking if anyone has looked into eBay's new digital service efficiency methodology for measuring data center efficiency.
I believe that's coming out on Dean Nelson's Data Center Pulse network. I haven't looked at it in detail yet. Right now I'm still staying with some of the larger organizations like Green Grid in terms of those. And there's some actually coming over from Europe that are more promising that really try to relate that relationship between work and power more closely. But I think what's going forward is just there's a lot of great ideas out there, and depending on the organization, they all have value because we all operate our data centers differently. And so I would hate to say, I still think there's not a one-size-fits-all in terms of efficiency metrics.
Okay. With that, we'll wrap up. I'd like to take this opportunity to thank Craig and his HDR team for the great presentation and for all 5 of you doing your section of the presentation. It really worked out well that way. Just would like to remind our attendees that you'll get an email today with a link to download a PDF of the slides. For Building Operating Management, this is Greg Zimmerman, and the webinar is concluded. Thank you.